Gravity doesn't exist, it's not a force, it's an illusion. Would you believe me if I said that? Why do I say that? Let's talk about it. In fact, it has something to do with apples and the moon. When an apple fell to the earth, Newton under the apple tree began to think. If there was an apple tree in the distance, it would be obvious that the apple would fall to the ground in the radial direction of the earth, or that the earth would draw everything in the radial direction to its center. This intellectual shift is critical, because Newton now thought that the earth attracted the apple with the same force as the earth attracted the moon. Which means the earth is pulling the moon toward its center. The moon does not fall on the earth because it is moving in a circle around the earth and gravity provides a centripetal force. By this time, people already had a rudimentary understanding of the moon, such as its angular velocity and the distance between the moon and the earth. So Newton was able to calculate the moon's centripetal acceleration. On Earth, Newton could easily measure the acceleration of the apple. So now Newton had 4 pieces of data: the moon's centripetal acceleration, its distance from the earth, and the acceleration of the apple, its distance from the earth. So can you see how these 4 numbers relate to each other? The ratio of the 2 accelerations is roughly equal to the ratio of the 2 radii squared, which means that the force of gravity is inversely proportional to the square of the radius, which is a pretty amazing discovery. So the next question is, what does gravity have to do with mass? Very early on, Galileo showed us that when an object is in free fall, its acceleration is independent of its mass. And by this time Newton had already derived the formula for the acceleration of objects, so it was clear that mass was only a factor of gravity. When you divide gravity by mass, the mass factor can be eliminated. So there's the formula for gravitation. And finally Newton added another constant to it, g. This is roughly how Newton discovered gravity. And then we know that everything in the universe is attractive. Newton's equation can explain as small as an apple falling to the ground and as large as the motions of celestial bodies in the solar system. But Newton always believed that his discovery of gravity was only a descriptive manifestation, and could not fully explain it. Indeed, in the last century, Newton's formula of gravity in Einstein's special theory of relativity, in the explanation of Mercury perihelion anomaly of the problem of contradiction. So Einstein used his general theory of relativity to geometrize Newton's formula for gravity, turning gravity into a curvature of 4-dimensional spacetime. He found that objects were not actually drawn to each other because of gravity, but because their trajectory along a curved region of spacetime behaved like an illusion of attraction. For example, that 2 two-dimensional creatures are on a 3-dimensional sphere, and they start at the equator and they go north in parallel. If they lived on a 2-dimensional plane, they would never meet, because parallel lines would never meet. But to our 3-dimensional creatures, they're actually following the curvature of the sphere, and the trajectory is a curve. So even though they were traveling parallel from the equator, they would still meet at the North Pole. Of course, in their eyes, they will always think they are walking in a straight line. These encounters are known to them as gravitation. So the space we exist in looks curved in 4 dimensions. We're just moving along our region of space. Let's say you fall vertically to the earth from a high altitude, but in 4 dimensions, you're really going on a curve. It's exactly the same way that we see people in 2 dimensions. Mass simply determines how much our 3-dimensional space is curved. So gravity doesn't really exist in general relative terms, it's just an illusion caused by the curvature of a region of space. But the universe is much more complex than we thought. Because in addition to Einstein's general theory of relativity, there was an even more profound revolution in the last century, quantum field theory. So Einstein's general theory of relativity is by no means the ultimate nature of gravity. It is too early to say that gravity is not a force. Gravity is the curvature of space. It is only in our current understanding. The theory of relativity will be replaced one day, because scientific discovery is trial and error. Until we find the ultimate mystery of the universe.